Good morning, viewers. This is Kasturi Day. Today I am back with the physics chapter, that is motion chapter. This is according to ICSE syllabus class 9. Okay. So before I start, I will request you to please subscribe my channel, and my existing subscribers, please do press the notification bell and continue with me so that you can get the notification as soon as the new video is uploaded. Okay. And if you are liking the video, press the like button, share with your friends so that they can also be benefited from these videos. And also, don't forget to meditate before you start your day. Okay, your whole day will be very nice. You will be doing some productive, very productive work if you meditate. Okay, and start your day. Believe me, it will help you a lot. I tell my daughter to continue with this meditation so that she also gets some benefits. She also got some benefit. Okay, so let us first start with the this one meditation for 1 minute, and then I'll start with the discussion. Okay, so for meditating, think of a point of light that is giving you energy, that is helping you to concentrate on what you are doing, increasing your concentration, increasing your interest in what you do. You're gaining that energy from that source of light. Your whole body is lightened up with energy. You're feeling very energetic, very enthusiastic, very lively. And you will enjoy what you do, not feel at all bored. Think everything as positive and speak very good things always in the whole day. Very productive you will become, successful in your course. So let us close now and we'll start with the discussion. So today's first topic, which we will start with the discussion of, is the difference between distance and displacement. Okay. So what is the difference between distance and displacement? We have studied before this in my last video about this chapter, that is what is motion, what is rest, and then we have started the discussion of distance and displacement. Distance, what is distance? Distance is total path which is traveled by a body in unit time. Okay, or displacement is the shortest path traveled by a body from its initial to the final position. Okay. Now, distance, we know it's a scalar quantity, that is, it has only magnitude but no direction. And displacement is a vector quantity having both magnitude and direction. Okay, that is, you need to write with the magnitude which direction is moved. It's the object is moving. That will be the displacement of that object. Now, distance is path dependent. That is, it changes. It's according to the path taken. Okay, like if the car is moving north, then it is moving south. It's turning a U-turn and then it is moving south. So it will move according to the path. But in displacement, it will be the shortest distance. So it is path independent. Okay, it does not change according to the path taken. It will be just a straight line. Okay, so that will be it is path independent. Okay, now the value is always positive in case of distance. The distance value is always positive, but in displacement, the value can be negative, positive, or even zero. Okay, when it is zero, when there is no displacement, that is, it is coming back to the same point. So that will be there is no shortest distance, no? So that's why the displacement will become 0 at that time. Next, distance always increases over time. That is, when time increases, distance also increases. But in some cases, special cases, displacement can decrease over time. Okay, but we can see that in some cases, what happens, displacement can decrease over time. For example, see, if a road moves northward, then to east, then to south, and then then to south. Okay, so that is distance increases as the time increases. Okay? But in the case of displacement, what happens? It may decrease over time, right? Because the displacement will be the shortest distance. So that is from, say, if a body moves like this, say, if a body moves like this, it moves like this, then it comes like this. So that will be the distance. Okay, but displacement will be this one, straight line. So displacement will decrease over time. Okay. Then the distance can be, it is denoted by small d, and displacement is denoted by small s. Then the distance can be measured along a non-straight path. I told you, no, it is moving like this it can be moving from one place to another in the way the object is moving. But in displacement will be a straight line. Okay. The formula of distance is equal to speed into time, whereas displacement is velocity into time. Okay. Now it is indicated without an arrow. Okay. This distance is indicated without an arrow, but displacement is always indicated with an arrow. There is an arrow above it that will, as it is a vector quantity. Okay. Next is, we come to speed. Okay. Now, what is speed? Sorry. It is the rate of change of position of time. What is speed? Speed is the rate of change of position with time. That is, changing position with time, with the time change. Okay. That is, it is the rate to which an object is changing its position per unit time. Like say in 1 hour, what is the change of the position of the object? So that will be its speed. It is also a scalar quantity like distance. It is measured as the ratio of the distance to the time in which the distance was covered. So how is it measured? Distance to time. That's a ratio. Ratio of distance to time. That is d by t. D is distance, t is time. So formula is S is equal to d by t. Now, the SI unit of speed is meter per second, but most common unit which we follow in daily use, that is kilometer per hour. It's long distance, no? So it's not measured in meter per second, but it's kilometer per hour. And in CTS unit, it's centimeter per second. Then the formula cannot be used where there are different speeds for different times, and total average speed is asked there. So what happens when there are different speeds in different times, then we take an average of that. We don't use that speed is equal to distance by time. That time we take the average speed. Okay. Or if the speed at a particular instant of time is asked, like in this much of time, what is the speed? So that time what happens, we take an average speed and not the main, just the speed that is distance by time. In most cases, objects move non-uniformly. Okay. Most cases, like if you are moving from your house to school by your bus, school bus, so it may be that the road is not uniform. Sometimes there is some ups and downs in the road. Okay. So that time the speed may be slower. Okay, and if it is a very good road, then the speed will be fast. So the rate of motion of those objects can be calculated in terms of average. So non-uniform motion, one non-uniform motion is there, and therefore what happens? They are told that that time there is the average speed is taken. So what is the average speed formula? It will be total distance traveled, how much distance you have traveled, that is calculated total, that is made you add the total distance and then you divide by total time taken. Like first you, for example, if you think that for 1 hour you move very slowly, then next hour you are moving very fast because the road is very ups and downs. First first hour, and then second hour it is very smooth road. So for first hour you must say you have covered around 10 kilometers, and in second hour you have covered say 20 kilometers. So what will be the total distance? 10 plus 20, that is 30, and the total time will be 1 plus 1, that is 2 hours. So what will be the total average speed then? Average speed will be total distance by total time, that is 30 kilometers, 30 by 2. That will be equal to 15 kilometers per hour. That will be the average speed. Okay. I think you have understood now. Next, we are moving to types of speed. What are the types of speed are there which we face? So first, there are generally 4 types of speed. One is uniform, variable or non-uniform speed, and then average speed and instantaneous speed. Okay. So uniform speed is that when an object is said to be uniform speed, when the object covers a distance in equal distance in equal intervals of time. Say for every hour, it is moving 10 kilometers. So the average speed will be, that will be a uniform speed. For every hour, that is 1 hour, each 1 hour it is moving 10 kilometers. Then for variable or non-uniform speed, I told you the first example that I gave, that is first 1 hour it is moving 10 kilometers, second 1 hour it is moving 20 kilometers. So that will be a non-uniform speed. Okay. Then average speed is defined as the uniform speed which is given by the ratio of total distance traveled by an object to the total time taken by the object. Then instantaneous speed is what? When an object is moving with variable speed. Average speed, uniform speed. Okay, it should be uniform speed, but in instantaneous speed, when the object is moving with variable speed. Okay, that is non-uniform speed. Then the speed of that object at any instant of time is known as instantaneous speed. Okay. Next is instantaneous speed is, the instantaneous speed is never less than or equal to 0. Instantaneous speed can never be less than or equal to 0. It is also a scalar quantity, and its SI unit is a meter per second, but the instantaneous speed of uniform motion is constant. If it is uniform motion, then the instantaneous speed is constant. That is, the magnitude of instantaneous velocity at any given time is the magnitude of instantaneous speed at that time. That means what? That when there is uniform motion, that time instantaneous speed becomes instantaneous velocity. Okay, that is, the motion is in particular. That is, say the speed becomes what? Uniform motion, uniform speed it becomes. Okay. Then, but at the time interval becomes small. As the time interval becomes small, instantaneous speed becomes a limit of average speed. If the time interval becomes small, say 10 seconds. So that comparison to 1 hour, it's 10 seconds is very small. So if the time is small, then the speed, the instantaneous speed becomes a limit of average speed. So instantaneous speed formula is distance traveled in a short time travel, okay, by time interval. Okay, so in short time, how much the distance is covered by time interval. And the speedometer of a vehicle measures the instantaneous speed. So instantaneous speed is measured by the speedometer of the vehicle. Next is velocity. Okay. So what is velocity? Velocity is defined as the distance traveled by the body in unit time in a given direction, or you can say the rate of displacement of a body. Okay? So it's a distance traveled by a body in unit time in a given direction. The direction should be must. It should be there. Otherwise, it will only be speed, not velocity. Velocity means you need to mention the direction. Or you can say the rate of displacement of a body is known as velocity in unit time. Now, SI unit is again meter per second, like that of the speed, but the most common unit of speed which we follow every day, that is kilometer per hour, and CGS unit is centimeter per second. But again, you have to mention the direction of the object, moving object. The formula is speed by, excuse me, not speed, it is displacement by time. Velocity is equal to not speed by time, that is velocity but it is displacement by time. Okay. So it is a vector quantity, so it has both magnitude and direction, and it is positive when displacement is positive and negative when displacement is negative. Now we come to types of velocity. Again, here also, we as like the speed, we will here also there are uniform velocity, non-uniform or variable velocity, then average velocity, instantaneous velocity, okay, then initial final velocity, then relative velocity is there. Now we come to uniform velocity when an object goes through equal displacements, that is the object is making equal displacements in equal intervals of time, then it is uniform velocity. Then the body is said to be moving with uniform velocity. Okay. Then that is, for example, see if a body is moving 1 kilometer every every hour, it is moving 1 kilometer in the direction north. You have to mention the direction for velocity. So it is moving north. So that is uniform velocity. If it is non-uniform or variable velocity, then the object goes through unequal displacements in equal intervals of time. For example, see if the body is moving every 1 hour, it is moving, so it is changing its displacement. That is, first it is 1 kilometer north, second for a second hour it is moving 2 kilometers north, like that. Then it is non-uniform or variable velocity. Okay. Then average velocity, it is the ratio of total displacement to the total time taken. Now formula is average velocity is equal to total displacement by total time taken. Okay. Now we come to instantaneous velocity. Instantaneous velocity is the velocity of a particle at any instant of time. That is instantaneous velocity at any instant of time. Instantaneous velocity is equal to distance traveled in a short time interval and divided by time interval. Short time interval, how much displacement has been occurred, by the time interval, that will give us the instantaneous velocity. Okay, then initial velocity. Initial velocity is the velocity at time interval. T is equal to 0 and it is represented by small u. That T is equal to 0 at that time, how much is the velocity? So that will be the initial velocity. Okay, time 0, then what is the velocity? Then final velocity is if it is the final speed of the moving object with an initial velocity, and it has an object should have its initial velocity, and what is its final speed of the moving object, and in which direction and acceleration over some time. Over some time it is moving, and it should have an initial velocity and its final speed and acceleration over some time. Then relative velocity, what is relative velocity? The relative velocity is of an object A with respect to the object B is the rate of change of position of object A with respect to object B. That is, if according to B, if two objects, as I told you, that if two objects are moving, say north, then According to B, A is also moving towards north. Okay, but if A is static and but he is in a, both of them are in a moving car. Okay, two cars are moving. Say, I'm giving a better example. That is, if two cars are moving, in one car A is traveling, in one car B is traveling, right? Then what happens? B will see that A is also moving. So in respect to B, with respect to B, the A is also moving with a velocity, right? In the direction of north, right? Same direction. Now, if the velocity that is in the same direction they are moving towards north. Now, if the relative velocity, what happens if car is coming from the opposite direction and B is going towards north, A is coming towards south, coming from south. Okay, so A is coming from north, B is going to north, A is coming from north. So B, according to B, the A is coming from north. Okay, so the relative velocity will be in opposite direction. So if VA and VB are the velocities of object A and B with respect to the ground, then the relative velocity of A with respect to B will be VA minus VB. And the relative velocity of B with respect to A will be VBA will be VB minus VB. Now, terminal velocity, when gravity takes over an object, okay, when gravity takes over an object, which makes the object to fall towards the earth through the atmosphere, then the constant velocity attained by the object is the terminal velocity. What happens if you drop an object, okay, from a distance above the earth? So the gravity is taking over the object, okay, then what happens? The object will fall freely towards the earth through the atmosphere, so that there will be a constant velocity there. Okay, so that time, that velocity is known as terminal velocity. Next is the difference between speed and velocity. What is the difference between speed and velocity? Speed is the distance covered by a body in unit time. Velocity is the displacement covered by the body in unit time. Speed is a scalar quantity, velocity is a vector quantity. Speed can never be negative or zero, whereas velocity can be zero, negative, or positive, like that of the displacement. Then the average speed will continue to count even if the object changes direction. Even the object is changing direction, going to north, then to east, then to west. Like that, if it is moving like that also, the speed, average speed will be there. But in velocity, if it is changing the direction, there will be no velocity. So for that, for velocity to continue, the object should move in one direction. Now, speed may or may not be equal to velocity, but velocity for an object may possess different velocities, but they have same speed. Speed is equal. Speed may or may not be equal to the velocity. Speed may or may not be equal to the velocity. But in case the object may possess different velocities, velocities may differ, but the same speed will be same. Velocities, because the direction may differ, but the speed should be there. Speed will be same. Okay. Next is a sports bike traveling at 50, it's an example. A sports bike traveling at 50 meters per second will go from 0 to 30 meters per second. So it's traveling at 50 meters per second. Its speed is what? 50 meters per second. So it would go from 0 to 30. Before reaching to 50, it will be from 0 to 30, then it will move to 50, and even it will cross that 50 limit also. So, however, the average speed will be the speed of the bike. You make an average of the speed, all the speeds, that is 0 to 30, 0, 30, 50, then 70. You make the average of the speeds, average of all the speeds limit which is there. and that will give the speed of the bike. But for example of velocity, what happens? A train going towards the south direction with an average speed of 50 kilometers per hour will have a velocity of 50 kilometers per hour north. Okay, that will remain the same because the direction has to be north. It is going towards south direction with an average speed of 50 and will have the velocity of 50 kilometers north. An object going straight in a particular direction is considered to have the velocity. It should move in a particular direction. It should move in a particular direction, then only it will have a velocity. Otherwise, there will be only speed, no velocity. Okay. So it should not be south direction. A train going towards the south direction will have the velocity of 50 kilometers per hour, will have a velocity 50 kilometers per hour south, not north. It will be south. Okay, so south direction it is moving, so it is moving south. So there should be particular direction will be straight. If it is moving straight with a particular direction, then only it will have a velocity. Otherwise, it will only have the speed and not the velocity. After one round in a circular path, the average speed is not zero because the speed will be the total distance by total time taken. So the total distance will be the total distance of the total circumference of the circular path. Okay. So this average speed cannot be zero. But in case of velocity, after each round in the circular path, the average velocity is zero. Why? Because the displacement is zero. So the velocity will be equal to zero. Okay. So I think I'll stop here. I'll continue with the rest of the chapter in my next video. I think you have understood this. And if you have any doubt, please do write in the comment box. I'll try to explain you why why it is happening so. And if you are wanting any tests of any chapter, you can also comment me and I will arrange for the questions. Okay. So if you are liking the videos, press the like button, share with your friends and colleagues so that they can also be benefited from these videos. And if you are a new viewer or you are an existing viewer, please do subscribe my channel and press the notification bell so that as soon as I upload my video, the notification will come to you. And don't forget to meditate before sitting for your studies in beginning your day, and in between your day also, in between your work also, you should meditate to get your concentration and also to increase your interest in what you do. Okay, so thank you for watching and have a good day.